Welcome back to the deep dive. Ready to dive deep into a world where reality feels more um, like a thought experiment
Yeah.
than like concrete laws.
I like it.
We're continuing this exploration of James Cobben's Nursery of the Gods,
Yeah.
specifically Chapter 3, where he kind of throws his head first into all the mysteries of quantum physics. You got your thinking caps on?
Always.
Good. Because Cobben doesn't exactly hold back. He jumps right into how quantum physics has, totally upended our understanding of how the universe works.
It's true. For centuries, we clung to this idea of a clockwork universe. Like everything unfolds predictably according to some set laws.
Right, like one giant cosmic game of billiards.
Yes.
Where, if you knew the starting conditions, you could predict the trajectory of every single ball.
Exactly. And that was the essence of classical physics determinism. But then quantum mechanics kind of threw a wrench in the works.
Well, it's like, wait a minute.
Yeah. What Cobben finds so fascinating is how it reveals this inherent unpredictability at the subatomic level. Suddenly, our billiard balls are behaving very erratically.
So instead of, nice, predictable billiard balls, we've got these subatomic particles like electrons.
Yes.
And they're not behaving as we expect.
Not at all. See, we used to think of electrons as these tiny, solid things.
Yeah.
But quantum mechanics says, nope. These particles don't actually exist in a fixed state until they're observed.
Hold on. You're saying these particles exist in a kind of limbo until someone or something observes them?
Precisely. It's like they exist in this cloud of possibilities represented by what physicists call a wave function. And this wave function describes all the potential states a particle could be in.
Okay, so it's like a menu of possibilities.
Yes.
But then what happens when we observe them? Does the menu disappear?
You could say that. The act of observation, which Cobben suggests involves consciousness, seems to collapse this wave function, forcing the particle to choose one state out of all the possible ones. And that is what's known as the collapse of the wave function.
So it's like the particle saying, okay, you caught me. I guess I have to pick a lane now.
In a sense. But the really mind-bending part is what this suggests about the role of consciousness. It's like Cobben's saying that our minds aren't just passive observers. We might actually play an active role in shaping the reality that we experience.
So it's not just that we don't know what's on the menu until we look. It's that by looking, we help determine what's on the menu.
Exactly.
It makes you wonder, how much of what we perceive as reality is a result of this interplay between, our minds and the quantum world.
Precisely. And this is where things start to get truly bizarre, even beyond what we've discussed so far. Take, for instance, this concept of particle-wave duality.
Oh, here we go. Time to buckle up, folks.
Yeah.
Last time Cobben mentioned particle-wave duality, things got really interesting. For those who missed our last deep dive, what does that even mean?
In the simplest terms, it means that things we thought were clearly waves like light can sometimes act like particles. And conversely, things we think of as particles like electrons can exhibit wave-like behavior.
It's like saying a basketball can also be a sound wave. Wait, what? How can something be two contradictory things at once?
That's the million-dollar question, and it's a question that really fascinated Cobben as he was delving into quantum physics. He uses this concept to highlight the paradoxical nature of the quantum world. See, our everyday experience conditions us to think in these binary terms. Something is either A or B, but quantum mechanics says, nope, reality isn't that clear-cut.
So it's not that light is switching back and forth, it's that it has the potential to be both.
Exactly.
It's like the universe is hiding its true nature behind a curtain, and we only get these, fleeting glimpses.
And those glimpses, as Cobben describes them, are filtered through our very limited human perception. Imagine trying to explain the concept of color to someone who's been blind since birth.
Wow. Yeah.
That's kind of what we're dealing with here.
That is a great analogy. Our brains are wired to experience reality in a certain way, and then quantum physics comes along and says, hold my beer. But if light and matter can be both wave and particle, what are they before we observe them?
That's where this concept of complementarity comes in. It's like the universe is showing us two sides of the same coin, but we can only see one side at a time. Cobben describes this kind of hidden reality using the term complementarity, this mysterious something that underlies both wave and particle behavior. It's a concept that goes beyond our typical way of perceiving reality.
So it's not just that it's hard to grasp, it's that it's fundamentally impossible for us to fully grasp it.
Exactly. It's like trying to, I don't know, fit a square peg in a round hole. Our language, our concepts, even our scientific instruments are all designed to make sense of the world in a certain way. But quantum mechanics keeps hinting at this deeper level of reality that operates by completely different rules.
It makes you wonder if we're even asking the right questions.
That's a question that Cobbin really grapples with throughout the book. He suggests that our language itself might be limiting our understanding.
Oh.
Yeah, like we're stuck in this world of nouns and verbs trying to describe something that might be more like, you know, a verb and an adverb all at once, if that makes sense.
It does, actually. It's like we're trying to write a symphony using only one note. But how does Cobbin propose we move beyond this? Like, how do we even begin to understand something that defies our very way of thinking?
He argues that we need to shift our perspective, move beyond this idea of the universe as just like a collection of individual things. He points out that quantum physics shows us it's all about relationships, interconnections.
So less like separate billiard balls, more like what?
It's like Cobbin uses this analogy of a spider web to describe this interconnectedness. Imagine a spider web, glistening with dew in the morning sun.
Mm.
Each tiny droplet of water reflects the light and creates this intricate pattern of sparkling light.
Okay, yeah, I can picture that. Beautiful and intricate.
Now imagine that each droplet represents a quantum particle. Just like each strand in the web affects the tension of the others, the properties of one particle are inherently tied to its relationship with others, forming this dynamic, interconnected system.
So instead of focusing on the individual droplets, we need to look at the web as a whole, at the way the droplets, interact and influence each other.
Exactly. It's about understanding the whole, not just the parts. And it's in these relationships, these interactions, that we might find the key to unlocking the deeper mysteries of the quantum world.
Okay, I think I'm starting to get a feel for this whole interconnectedness thing, but I have to admit, it still feels pretty abstract. Does Cobbin offer any more, concrete examples to kind of illustrate how this plays out?
He does. He discusses a couple of famous experiments that really highlight these strange quantum phenomena. Have you ever heard of the double slit experiment?
Vaguely. It's the one where you shoot electrons through a couple of slits, right? And then things get weird.
That's the one. Cobbin describes it in detail because it's like a classic demonstration of particle-wave duality in action. The experiment involves firing electrons, one at a time, at a screen with two slits in it. Now, if electrons were just particles, like tiny marbles, you'd expect to see two distinct bands on the detector screen behind the slits, right?
Makes sense, like throwing tennis balls at a wall with two openings. You'd see two clusters of marks where they hit.
Exactly. But that's not what happens. Instead, we see an interference pattern, like waves overlapping and creating areas of high and low intensity. It's as though each electron is going through both slits simultaneously, interfering with itself. This clearly demonstrates the wave-like nature of matter, even when we're talking about something as seemingly solid as an electron.
So an electron can be in two places at once. My head is starting to hurt.
I know. It's a lot to process. But it gets even weirder. You see, if you try to observe which slit the electron actually goes through, the interference pattern disappears. It's like the act of observation forces the electron to choose a path. It collapses that wave function and forces it to behave like a particle.
Hold on. You're telling me that by simply observing the experiment, we change the outcome?
That's what the evidence suggests.
Yeah.
And it's one of the most mind-blowing aspects of quantum mechanics. It's as if our consciousness, our very act of looking, has a tangible effect on the quantum world.
Okay, that's just wild. So we've gone from billiard balls to electrons that can be in two places at once, to our minds influencing the outcome of experiments. What other examples does Cobbin offer to try and, make sense of all of this?
Well, he also discusses another fascinating phenomenon, quantum entanglement. This is where we really start to see the limitations of our everyday language and experience.
I'm almost afraid to ask. But tell me more about this entanglement.
Basically, it involves two particles that are linked in such a way that even when they're separated by vast distances, they remain connected. It's like they have this invisible thread tying them together.
Okay, so they're connected. But how?
That's the thing, we don't fully understand the how. What we do know is that if you measure the state of one entangled particle, you instantaneously know the state of the other, no matter how far apart they are.
Wait a minute. Isn't that faster than the speed of light?
Hey,
I thought nothing could travel faster than the speed of light.
you're right. This spooky action at a distance, as Einstein called it, seemed to violate his theory of relativity. He believed there had to be some hidden variable, some undiscovered property that could explain this instantaneous communication.
But as Cobbin points out, later experiments actually proved Einstein wrong on this one.
Yeah.
Entanglement is real, and it really does seem to defy our conventional understanding of space and time.
It does. It makes you wonder if, like, our concept of distance is even, like, as straightforward as we think it is. These entangled particles behave as if they are part of a single unified system, even when separated by these vast distances.
So it's like they have this, I don't know, this secret communication channel that transcends the limitations of space and time as we understand them.
That's the idea. And
Okay.
it's this interconnectedness that Cobbin finds so compelling. He's saying it challenges us to consider the possibility that there's this deeper level of reality, one where, like, separation is an illusion and everything is fundamentally interconnected.
Okay, I think I'm starting to see the common thread here.
Yeah.
We've got the collapse of the wave function, particle wave duality, entanglement. It's like Cobbin is building a case for a very different kind of universe than like what we're used to.
Exactly. He's inviting us to consider a universe that's less like a machine and more like, as he puts it, a giant thought experiment.
A thought. That brings us back to consciousness, doesn't it?
Mm-hmm.
Is he suggesting that the universe is one giant mind, like thinking itself into existence?
He doesn't explicitly say that, but he does leave us with the question, if the universe is a thought, whose thought is it? And what does it mean for us as conscious observers to be, embedded within this cosmic tapestry of thought?
Whoa, that's a pretty profound question, and I'll admit, it's a bit unsettling. Like, does Cobbin offer any guidance on how to even begin to wrap our heads around such a concept?
He suggests that maybe, just maybe, the answer lies not in searching for some, external thinker, but in recognizing the interconnectedness of all things, including our own consciousness.
Yeah.
Maybe, as he suggests, we're not just passive observers in this, like, cosmic dance, but active participants. Our thoughts and intentions, rippling out into the fabric of reality.
So we're not just watching the movie, we're writing the script as we go along.
In a sense, yes. Cobbin challenges us to consider that our understanding of the universe is limited by our own perception, by the very structure of our language and thought.
It's a lot to process, that's for sure. It's like he's pulled back the curtain on this whole new dimension of reality, one that's both exhilarating and terrifying.
And the most exciting part is that we're only just beginning to explore its depths.
Well, listeners, there you have it. Another fascinating deep dive into the mind-bending world of James Cobbin's Nursery of the Gods. We journeyed from the subatomic realm to the cosmic, grappling with concepts that challenge our very understanding of reality. We explored how quantum physics has thrown a wrench into our neat, deterministic view of the universe, revealing a world where consciousness might play a much more active role than we ever imagined. And while we may not have all the answers, one thing's for sure. This deep dive has left us with plenty to ponder. Until next time, keep asking those big questions and never stop exploring the mysteries of the universe, both within and around you.